All right. Hello, everybody. Let's go ahead and get started. First off, just an announcement / an apology. I was hoping to have the homework 3 grades back, and a good portion of you do have homework 3 grades back, but a significant number of you still do not, and that is entirely my fault. I have been very sick the last few days. Today's the first day I've left the house in 3 days. I'm not feeling great at all. I was this close to canceling class today, but then I thought about how disappointed you all would be, and that was the motivation that I needed to get my butt out of bed and down here. In all seriousness, though, it is at the top of my to-do list. It's the top of my list of priorities. If we didn't have this assignment going out today, I probably quite literally would have canceled class. It hurts just to talk, so I'm going to try and keep today short and sweet. I do want to talk to you about the assignment. I do want to keep things moving. I'm going to do as little talking as I can get away with today, and I'm very sorry about the homework 3 stuff. I'm starting to slowly recover, and as I get better, I will get those done as soon as I possibly can. I'm sorry that they weren't done before now. I'm doing the best I can, guys. It's been a little bit of a struggle, so thank you for your patience. Thank you for bearing with me as I make it through this. Homework 4 is due tonight, as I'm sure you are aware, and homework 5 is going out today. This is the last homework assignment, so the only things you have left to do for me are this assignment here and a final exam, which we'll talk about after Thanksgiving break. We don't need to talk about that today. Any questions about scheduling or homework 4 stuff before we talk about homework 5 today? Any questions at all? All right, so let's have a chat about homework 5. I would hope that it would come as no surprise to you that homework 5 is going to be based around the stuff we've been talking about related to Mongo. And so we did a demonstration of MongoDB in class on Wednesday of last week. What I'm asking you to do for homework 5 is going to be related to that. Now, in practice, the kind of stuff that I showed you in class last week with the console, the command line, is not how people would normally interact with Mongo. Normally, we interact with Mongo through an API. So I'm going to write my program in whatever language I want to write it in, and we'll use the API to talk to the database. And so what we're going to do for this assignment is essentially implement Mongo, a very small subset of the Mongo API, actually, for Java. There are lots and lots and lots and lots of references to the MongoDB driver for Java linked throughout the homework assignment. You're going to want to have this page up as you're working on this assignment. You're going to want to be referring to the API. The goal here is to implement a very, very simplistic, very small subset of the features that this Mongo database Java driver provides to us. And so what I'm going to do now is kind of go through the 4 pieces that I'm asking you to implement, and then we'll spend some time writing some unit tests today, like we've done for past homework assignments, and then I'll turn you all loose. So one thing to note is that because this assignment is so different from all of the prior assignments, it does not build off of any of the prior assignments at all. I've put it in a different repository, so you're going to need to make a new copy of this repository, a new fork of the repository, just like you did back for homework 1. You can refer to those instructions if you need to. There are 4 files in the project that have stuff for you to do in them. Some of them are quite short, others a little bit less short. The first file that I want to take a look at is this document class. All of the methods that I'm expecting you to implement are already stubbed out for you. You are, of course, are welcome to add any more methods that you want, right? Go nuts. If you need additional methods to help you out, please add them. But I'm expecting you to implement the methods that are already contained in the file. And this is actually a very simple class. It's mainly for convenience purposes. In order to effectively test our implementation, we need a way of taking JSON and converting it into objects, and then vice versa, taking objects and converting it back into JSON. We are going to use a parser for this because parsing JSON, while certainly an important topic, is a very tedious and not entirely relevant topic to us. So I have provided you with this JSON parser that you can use to parse things from JSON to Java objects and vice versa. And I provided you a link to some important things from the JSON library that you're going to want to use. In particular, I think it's worth mentioning that the, sorry, where did the lab write-up go? JSON parser object, this is what I'm looking for. In particular, this JSON parser object with the parse method is going to help you a lot with the methods in this document class. I'm going to be very upfront with you guys. These methods should be very short. This class should not take you very long, should not take you a very huge amount of time, should be very short. You should get away with a few lines tops for each of those methods. Should not be terribly complicated. What these methods will help you do is kind of get familiar with the JSON parser and the objects that you're going to be getting back, because we're going to be dealing with our Mongo data in the form of Java objects later on in the lab. Okay, so this would be a good place to start, and we'll write some unit tests for this a little bit later on. The next file to take a look at, and another one that I expect to be fairly simple, fairly straightforward, is the database class. So in the database class, you can see there's not a whole lot of methods. There's a constructor, and there's get collection, and there's drop database. This is going to manage the actual files themselves that contain the data in our Mongo database. And the structure that I want you to use, the write-up goes into this in more detail, but the structure that I want you to use is, all data is going to live in this test files folder. If I create a new database, that's going to be a subdirectory within the test files folder. So if I create a new database in my Mongo database implementation, you will have to physically create a new folder inside of test files where that database lives. So if I create a database called CSE530, I want to see a folder called CSE530 appear in the test files folder. That's what I want to see, right? And then any collections, so a collection is just a file. It's quite literally just a JSON file. So then any collections will be JSON files that exist within that folder. So if I have a collection in the CSE530 database that is called homework, right? I would expect to see a folder called CSE530 in that folder. And inside of the CSE530 folder, I would expect to see homework.json as the file for that particular collection. Does that make sense? So your job then is to, if the collection already exists, it's very straightforward. We're just going to construct one of these DB collections, which we'll talk about in a moment, and return it. If the collection doesn't already exist, you need to make the directory and make the file. So there's a little bit of file management going on in this class. That's really what this class is doing, is file and directory management. That's a big part of what it's doing. This should also be a very simple, very straightforward class. It should not be terribly complicated. So if a database is just a folder with files in it, then what is dropping a database? What would that be? Deleting a folder? Right? Just deleting the folder that has the stuff? Okay? So more file management oriented kinds of stuff. Any questions about that before we take a look at the last two classes? So the last two classes are where things really step up a notch and where the true Mongo implementation starts to take shape. We've got DB collection class, which represents a Mongo database collection. And so you can see the methods that I'm asking you to implement are find, which is, how do I query? But remember that we can also pass along parameters to the query. So here you see that I have another find method that allows me to specify query parameters in the form of a JSON object, right? So I can encapsulate those in the form of a JSON object, just like we saw in the demo in class on Wednesday. And then, excuse me. Here I have two JSON objects, one for the relational select and one for the relational project. We have a way to insert one or more documents. Have you guys seen this syntax before with the dot dot dots? Does somebody know what that means? Has anybody seen that? I can give you multiple JSON objects if I want to. Or in other words, in the code, I can treat this as a collection. I can actually iterate through the documents and grab them one at a time if I want to. It's a nice little piece of Java syntax for us. So insert the documents into the file one at a time. And let's see, we can update a document or more than one document. And we can also remove documents. We can delete documents. And then some simple getters down here for utility purposes. Count, the name of the collection, and getting the documents at index I. Okay. So while it may look like there are there's more stuff to do here, and it's true that there is more stuff to do in this class than in some of the previous classes, you'll notice that a lot of these return DB cursors. So the query things in particular return DB cursors. You can think of a DB cursor as very similar to an iterator that's going to allow us to go through our results one value at a time and then do whatever we need to with that particular piece of data. That is the last class that you're actually tasked with implementing. So you can see we've actually implemented the iterator interface here. We're iterating over JSON objects, and we're going to be able to tell you what the next JSON object is that matches the query, how many things are in the query. Now, one thing I want to point out is that this class looks fairly simple, right? Because there's not a lot of methods for you to implement here. But actually, I think a good design would do most of the query execution in this class, not the collection class. I think the collection class should actually simply delegate a lot of the necessary functionality to this class. So in my past experience, I've found that this class is the one that probably is going to take the most of your time and energy to implement correctly. It's doing a lot of the heavy lifting. It's doing a lot of the actual querying, making sure that the documents that are returned are actually matching the query parameters that you have been given. The DB collection class, if you do it right, a lot of these find methods can be one-liners if you have a very nice clean design. So if you start writing these and you detect that you've just got a whole lot of code in these find methods, you might want to pause for a second and ask if you can maybe clean that design up a little bit. Maybe you're doing some stuff in the wrong place, perhaps. I think if you take some time and plan some stuff out ahead of time, this DB collection is not going to be that tricky for you. But if you just dive right in and start throwing code to see what sticks, you could definitely end up barking up the wrong tree, taking a wrong turn somewhere, and costing yourself a bit of time. So definitely worth it to take some time to come up with a plan. Make sure you understand what each of these methods is trying to do, and sketch out some examples on paper of how you expect these methods to work before proceeding. Are there any questions about that's the tour? Those are the 4 files that you're asked to implement? Yeah.
So since we need to fork another report, we need to send another invitation?
Yes, unfortunately, that means you'll need to send another invitation, and the invitations are a big pain in the ass. I will be checking my email regularly over the next few days. On the topic of invitations, if I could please request that you send me one invitation. I know sometimes people get anxious when I don't accept that invitation right away, right? Please, 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 please resist the urge to, sorry. Please resist the urge to send another invitation right away. It's much easier for me if you just send one invitation and you be patient. Please wait. I will find the invitation and accept it. It might take me a minute, but that is the best way to proceed. Yes, thank you for asking. Any other questions? I'd really love some questions so that I don't have to talk so much. If anybody's got them. All right. If there aren't any questions for me, then let's talk about the last major piece of this assignment. For every assignment up until now, we've had kind of a thing going, right? Where you write some unit tests, I collect all the unit tests, and then sort of go through and filter them and give you some unit tests back to use. Well, it is time for the baby bird to leave the nest, so to speak. I'm not gonna give you any tests for this one. You guys are on your own now. You've had lots of experience writing tests. I hope that you've taken that seriously. I hope that you're not caught by surprise. This has been the plan the whole time. I have been leading up to this moment the entire semester, pretty much. So you guys are going to be responsible for writing your own unit tests. Please, please, please do this first. Write the tests first. Don't write an implementation and then write tests to match your implementation. No, 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 no. Write the tests first. Write the tests ahead of time. Use the tests to define the behavior that you want your program to have, right? Use the test to tell me a story about how your program should work. When I'm grading these things, I should be able to look at the unit tests that you've written and understand how your code is going to behave without even looking at the DB collection files or any of the other stuff at all, right? You should be able to look at those tests and have a clear idea of how you expect your program to work. So when it comes to writing unit tests, some things that you should definitely, we'll have a brainstorming session of things that we should be testing, right? We'll do that coming up in a little bit. But I do think that it's important to point out that there are some simplifications to the Mongo spec that I've given you guys in terms of testing, so especially as it relates to queries. Because the number of queries that we could write are infinite, right? And we only have a little over 2 weeks until the end of class. Actually, this is due on Friday, December 6th, the last day of class, which is my birthday as it happens. So that'll be my birthday present from you to me. Thank you in advance. But yeah, to keep things simple, I'm not asking you to be able to handle any possible query that comes in, but there are some things that I want you to pay attention to. For starters, the only types, I think I list the types up here. Yeah, the only types that I'm expecting you to be aware of are strings, so simple key value pairs where the value is a string. I want you to be able to handle embedded documents, and I want you to be able to handle arrays. And I also want you to be able to handle combinations of those things. So an array of documents, or an embedded document that contains another embedded document, or an embedded document that contains an array. Now, one of the issues with this is, when does it stop, right? I can keep nesting those things indefinitely. Mongo actually has a cap on this. That cap is, I think it's like 100 layers of nesting. I'm asking you guys to handle two layers of nesting. Don't worry about getting too crazy with it. That actually simplifies things a lot, a very large amount. So what do I mean by 2 layers of nesting? That means that I should have a document that could have a list of documents in it. That's 2 layers, the list and then the documents themselves, right? Or I could have a document that has an embedded document that has another embedded document. That's 2 layers of nesting, right? Or I could have a list with a document that has another list in it. That would be, I would consider 2 layers of nesting. but I won't expect you to handle any nesting levels deeper than that. So as you're writing your tests, as you're pondering what queries you should be able to implement, please keep that in mind. Nesting only has to go 2 levels deep at the most for this. And then as far as operators, I'm expecting you to implement the comparison operators for your queries, which I've linked you to the documentation here. Anything that comes under this heading of comparison, I'm expecting these operators to work. It's a very straightforward list: greater than, less than, equal to, right? Don't worry about the logical operators. Don't worry about these operators down here. I just want the things under this header of comparison operators to implement. So that's a large part of the spec that you are not responsible for. I'm trying to keep this a little bit simple for the sake of time. Give you a little bit of a break on implementing the whole spec in 2.5 weeks would just not be a feasible thing to do. So keep that in mind when you're writing your tests. That should help you narrow down what tests you need to write, what behaviors you need to cover when writing your tests. As far as the tests themselves, I've actually given you 4 files here: collection tester, cursor tester, DB tester, and document tester, 1 for each class. So please try and keep things organized. I will read these tests. I will run these tests when you submit your assignment. In fact, we're going to spend some time now talking about what tests we should write, and maybe even writing a few tests. That's the next thing I've got on my agenda. Yeah, what's up?
Do we submit tests by Wednesday, or
just only at the end when you're done?
Okay.
Yeah, only at the end when you're done. I'm not going to give you any tests. I'm not going to redistribute any tests.
Also, how many tests are you looking for? Just our own judgment, or?
So I thought about putting a limit on it. So I've given you a list of requirements, right? And I would expect your tests to prove to me that you have fulfilled that list of requirements. How many tests does that take? I don't know. More than 1, less than 100, right? Probably less than 50, probably less than, I don't know. Now we're getting into gray territory. Less than 30, maybe. If you're really good at writing tests, I could believe that, yeah. But it's hard for me to put a hard number on how many I'm expecting. That is a part of your grade, though, is the test that you submit to me. Yeah, and that's on the rubric for this problem as well. So I don't want you guys to be left completely hanging on the test. Yeah, question?
Yeah, so are we just responsible for passing the test results, or are we responsible for all the tests?
No, I would not expect you to have any idea what other test people have written. In fact, because the tests are part of the submission, looking at other people's tests, I would consider to possibly be a violation of the integrity policy for this assignment. You are writing your own tests. You're responsible for your own tests. Yep. Now, that being said, I think having a conversation with your classmates about what you should be testing for, that's a great idea, right? What you should be testing for, please talk about that with your classmates. We're going to have a conversation about that right now. But be careful with your tests. Sharing your tests openly could be considered an integrity violation for the purposes of this assignment. I want to see how much of this emphasis on unit testing you have taken in over the course of the semester. That is something that I want to see on this assignment. I want to make it clear to you guys that if you spend some time up front thinking about these tests and writing some really nice unit tests up front, it's going to make completing this assignment much easier. I promise you it will. If you spend some time thinking about your unit tests and spending time writing really good unit tests, it will make completing the rest of the assignment much easier. I promise. I promise it will. But let's talk about it. Let's start with document tester and come up with some ideas of things that we should be testing for. Now remember, the document class, just as a little refresher, has 2 methods in it: parsing JSON to JSON object, and then taking a JSON object and converting it back into a string. right? So what are some situations, what are some cases that we should be on the lookout for when converting things from JSON into strings and vice versa? What are some things that we should watch out for? Yeah. Invalid JSON. So let's make some comments here, and I'll post these to the repo once we're done talking about it today. Things to consider testing. Invalid JSON. Anything else we should be aware of? Think about the special cases that Mongo presents to us, the database itself. What are the forms of JSON that we should be aware of? What are the unique things about Mongo that distinguishes it from other databases? That sounds like an exam question to me. Yeah. Embedded documents, yeah. Properly parses embedded documents. And we've got the other one too, right? Properly parses arrays. Right? And then we've got the opposite direction too. I can take a document object and put it back into JSON, right? And go the opposite direction as well. So object to embedded document, object to array. And there's actually, we're forgetting maybe the most simple case here, just a simple key value pair. We want to cover that as well, simple key value pair. So that would actually be using the Mongo API. You would see that that would actually be referred to as a JSON primitive. A simple key value pair, it's just a JSON primitive. So object to primitive and properly parses primitives. I think that's it. I know this might look like a lot. I know it looks like that we just set up 7 tests here, perhaps. But just to show you what one of these tests might look like, let's write one of them. Let's write one of these tests. Let's test parsing a primitive, a simple key value pair, and see if we can properly do that. So test parse primitive. I need a primitive. I need a key value pair. I need that in JSON format. I can actually just do that as a string. There's no reason that I can't just simply do that as a string. So string JSON equals curly brackets to start the document. I'm going to use quotes inside, so I have to escape them, right? Key value. That's about as simple of a JSON document as we can get, right? Let's not get any less complicated than that. It's a very simple key value pair. Very straightforward, very simple key value pair. I want to try to parse it and make sure that I can get that into a JSON object. So we'll call the method. So remember, unit tests have 3 parts. We've got the setup. This is the setup, preparing the variables that we need. We're going to call a method from our program. In this case, what method are we going to call? We're going to call document.parse, which takes in a JSON string and returns a JSON object. And then we verify the results. So I'll call document.parse. I don't know what that error was. I'm going to ignore it. Oh, but I want to grab the return value, so it's going to return a JSON object, right? JSON object results. And now I just need to verify. Now I just need to verify the results. This JSON object, if we look at it from the this JSON object, you can see it consists of key value pairs, and the values are any other type of JSON element, where a JSON element could be a document, could be a primitive, it could be an array. In this case, we expect it to be a primitive because we just have a key value pair. I'm not talking about embedded documents. I'm not talking about embedded arrays. I expect it to be a primitive. So if I look at some of the methods down here, you can see get as JSON primitive, where I pass it a string. This is the key. It's going to give me a JSON primitive as the value back. Since this is a test for primitives, that's what I expect. So I should be able to say results dot get as JSON primitive, pass in key as the key, and then I want to make sure that it gives me back the right value. It gives me back the right value. So how do I get this value out of the JSON primitive? Well, let's go to the API and look at the JSON primitive class here. See if there's a way to get the value out. So you can see there's a whole bunch of get as's here, right? The only thing that we're concerned with are strings, so I can say get as string. Since string is the only primitive type that I'm interested in, get as string, which will return the string, and then finally an equals should do the trick. I'm just missing one final piece. What's the last piece that I need for this to be a good unit test? I need an assert. I need an assert. Assert true. That's kind of a monstrous line of code. I might want to break that up possibly, but I think the process is. I think the logic is sound. Here we go. Here's a test. Already done. One test down. So for properly parses primitives, I'll just make a markup here. Done. I've written a test. Is this test going to work? Nope, not yet, because I haven't actually implemented the parse method yet, right? But I've written a test that should give me an indication of whether that method's going to work or not. Are there any questions about how I got this test, or what this test is actually doing? So setup, call method to be tested, and then verify results. That's the process that a unit test should take. They're all going to follow a similar trajectory. We can keep doing this for the other ones as well. We can have brainstorming sessions for the other ones too. So let's take a look at database next. Go into DB tester. Where's my DB tester? Here we go. Excuse me. So if I look at the DB class, there's not a lot to it, but you see in the description here, if the given database does not exist, it should be created. So this might have to create a folder, possibly. Might have to create a file, possibly, if I access a collection that doesn't exist. It might have to create that, and I have the ability to drop as well. So what kinds of things am I going to be testing then? Let's make a list. Things to test. Consider testing. What do I need to test? What's on my to-do list? Well, let's just start at the top. creates a database object with a given name. So here I see I've got two potential situations, right? Either the database already exists or it doesn't. So I want to have tests that kind of handle both situations, perhaps, right? Or maybe it's even simpler than that. I should be able to create a database with any name that I want and then verify that that directory exists afterwards, correct? Whether it already existed before or not is kind of irrelevant. So, properly creates directory or new database. That's something we should test. If the database already exists, properly accesses existing directory or existing database, right? What else? What else do we need to test? Here I've got get collection. So I should probably write a test for this so that I can access and create this collection object, return it to me when I request a collection. And the last method for dropping a database, right? Properly deletes a database, properly drops a database. I think that's pretty good, right? There might be some edge cases in there that I'm not considering, but this covers most of the main functionality that I would expect this class to be responsible for. So let's write a test. Let's just do this one at the top of the list. Properly creates a directory for a new database. If I come down here and write a test, test create DB, I should be able to create a database object. That's my setup, right? I should be able to create this database, and by executing this line of code, what do I expect to happen? I expect a new directory to be created called homework 5. I should be able to verify that that directory does in fact get created and exists. The way to do that is by using a file object. File test files / homework 5 dot exists. Wrap that in an assertion. We have written another test. Done. Mark that off of our to-do list. We have written another test. Very simple. In this case, there wasn't even any setup. Call the method verify results. There wasn't even any setup. Any questions? Yeah. Special character. Yeah, so that's a good question. That's a decision that's up to you, honestly. Special character handling. Write a test and tell me how you expect that behavior to work. It doesn't bother me either way. Which means that nobody's gonna handle special characters now, I understand that. But if you feel strongly about it, write a test. Tell me what you think. This is your assignment. You get to choose what direction it heads in. Any other questions? Yeah, what's up?
Is this data going to be writing to files specifically,
Yeah, there is going to be some files manipulation stuff going on. And that's a good question. So we talked about this last Wednesday, right? How Mongo uses BSON binary JSON. We don't have time for that. That's quite frankly, we don't have time to get into that. So plain text is the way to go. In fact, before we leave here today, I'll set up a test JSON file for you, and give you. I'll commit an example of that as well that you can use.
Are there some libraries?
BSON. So there probably are BSON libraries, but it's important to note that Mongo uses Wireshark, which is a proprietary implementation. So I doubt that that is very easily accessible. But BSON is any form of binary JSON, really. So I'm sure there are open source implementations of BSON libraries that you can access that will be slightly different than Mongo's proprietary version. Yeah, I don't think Mongo opens that up. I could be wrong. I don't think that they do. We've got 2 more classes to go, which are probably actually some of the more important classes. Let's take a look at the collection class next. Collection tester. Things to consider testing. So recall that this collection tester, here it is, has methods for executing queries, right, and returning DB cursors. Also has methods for inserting, updating, removing, and some simple getters and setters for count and get name, get document. Okay. So if I want to test this, there's really a lot more stuff for us to branch out and test now, right? It's quite a fair amount of stuff for us to branch out and test now. Although this is sort of a good question for us to talk about. With the queries, there's a lot of different queries that you're responsible for. Is this the place to test for them, or is DB cursor the place to test for them? I don't actually know. That could be dependent somewhat on your implementation, how you intend to implement those particular methods in your own specific repository. But I certainly wouldn't be upset to see them in either place. If you want to dump a bunch of query testing methods here, that's okay with me. If you want to dump a bunch of query testing methods in the cursor tester instead, that would also be okay with me. It's somewhat implementation specific. But if query testing is what we want to do here, there's several queries that I'm asking you to be aware of, right? So the simplest query is going to be what? Simplest query. If I look at the very top of the DB collection, I see a method. It just says all of the documents, right? Find all. That's the simplest one. So let's make a note of that. Where am I at? Wrong file. All right. Find all. All right. What other queries do I have? I have queries that do various. I have too many tabs open. Sorry. Let me clean some stuff up here a little bit. All right. I have a find method that takes in a relational select. So find with relational select. But that actually is not so straightforward, right? With relational select, I can do things like conditional operators. I can do things like embedded documents or arrays, right? Those are all things that I'm expecting you to take care of. And then we've got find with a projection as well, with a relational project. So find with relational project. Okay? And that's just for the retrieval of information. We also have inserts, updates, deletes. And we've got some other methods in here too. Insert, update, delete, count, actually get document. So for these getters, they're simple enough that I'm not sure that I'd be too upset if you didn't test them, but get document. And drop too, you could argue as well. Get document. Oops. So this list is quite a bit longer than the last ones, right? Quite a fair amount longer than the last list of things that we've seen. And actually, in order to do this properly, it almost relies on having a working DB cursor. So in order to run a lot of these tests, like the queries, it really relies on having a working DB cursor class as well, not just DB collection, but also DB cursor, which makes these tests a little bit more complicated, makes them feel a lot more like integration tests with two classes working together, as opposed to pure unit tests. But let's do get document real quick, because I think that's kind of a nice, simple, straightforward test. Test get document. So for this one, what do I want to do? I want to grab a collection, and I want to tell it to retrieve a document out of that collection, and then verify that the document that it retrieved is valid. So I could say something like, first I have to get a database, and we'll call this data. Once I have the database, I now have to access the collection. So the database class has a get collection method. db.getCollection test. And actually, these two lines of code tell us what the file structure we would expect to be. If I wanted to actually create a simple JSON file for testing purposes, right? What would I need to do to access this collection? Step one. What's the structure here? I'm telling you there's a database called data and a collection in that database called tests. So what does that look like in terms of file structure? What do I expect to see?
Folder called DD and a collection document called test.
Close, yeah. Folder called data, yep.
Test.json.
And then test.json inside of that folder. So I'll make a folder here. I'll call it test. And I'll make a JSON file. New text file. Kind of zoom in on this. There we go. And since we're dealing with plain text here, right? We can just type out our JSON directly. So I can say key value. And okay, there's one document. Doesn't have to be complicated. There's document number 0, right? There's document number 0. But I can put in more documents. And one thing that I would recommend is, in order to clearly clearly distinguish one document from another, you might want to have some kind of a delimiter in between the documents, so you can clearly see when one document stops and the other one ends. You might argue that, well, hey, isn't that what the curly braces are for? And the answer is, yeah, kind of, but I can have embedded documents, which are going to have more curly braces, so it becomes a more complicated problem to use curly braces to parse those documents individually. So you don't have to do this by any means, but I don't think it would be a terrible idea to put some sort of a delimiter here. Like even a blank line wouldn't be a terrible delimiter here, just to give you an easy way of breaking between one document and the next, or you could use like a tab, something, right, to indicate that this document is over and I'm about to start another one. And so I can make another one that says embedded and put in an embedded document, key 2, value 2, right? And maybe another one that has an array. One, 2, 3. These are all valid JSON documents that I would expect your implementation to be able to handle. And so you are free to, okay, so it wants me to save this. I need to call it test.json, and I need to put it into the proper folder, which is going to be down here. That folder that we, I'm sorry, I named the folder wrong. I blame the NyQuil, or the Dayquil. I can fix that. Refactor, rename, data. My fault. All right. And so now I have a database called data, and I have a JSON file called test.json. And I can access that within my unit test if I want to. I can make test data that will allow me to do stuff like this, and I have actual data that I can work with. This is going to be a necessity if you want to do things like test queries, right? You're going to need to make up some JSON data that you can use to test your queries. You're going to have to do that. But if I want to finish this simple test for get document, I could do something like well, I want to use the get document method. So I could just get one of those documents out of the file that I just created and verify the contents, right? Test.getDocument at position 0. That should give me the simple primitive key value. And I can just check and make sure. Oops, I forgot to stash this in a variable. My fault. And this will look very similar to a test that we had before. Primitive.get as JSON primitive with the key get as string equals value. Oh no. Anytime I see that many parentheses at the end of a line, I start to feel bad. That can't be right, can it? That's got to be too many, right? Oh, this is making it worse. It was too many, yeah. It was far too many. All right. I don't know why that happened. Yeah. So there's a very simple test for accessing a document. And I'll say done here, but I'll put a question mark because I do feel like we could maybe do a little bit more thorough testing on this method, but we've at least gotten a start on it. I forgot to put the test annotation on this guy. And we've just got one more to go. The cursor. So let's take a look at the cursor and write a test for the cursor. And then I'll turn you loose. Sorry, just doing some tab management here real quick. All right, cool. Things to consider testing. So what can a cursor do? It can tell me whether or not there are more documents, retrieve the next document, and tell me the count, right? It seems very straightforward. Seems very straightforward. So I could write a very simple test for, I don't know, find all the documents in this collection and then just make sure that I can access all of them, right? In fact, the collection that I just made has 3 documents, right? I can see them, 1, 2, 3. So find all the documents and just make sure that there's 3 of them there, right? Should be a very straightforward test. So, you know, has next count. It's not, I mean, this one is not very complicated, right? Has next count and next. Let's write a simple query for find all. So I want to run a find all query. I can actually run it on this exact JSON file that I just did. In fact, I'm going to come over here and borrow these 2 lines of code so I don't have to type them out again. DB cursor results equals test.find. That should give me all of the documents. All of the documents. So I should be able to do some testing here. Like I should be able to say assert true results.count is equal to 3. There are 3 documents, right? I should be able to assert true results.hasNext because there should be another document that I can access through the cursor, right? That should be something that I should be able to access. And then I should be able to go ahead and start burning off, you know, I could say something like document 1 equals results.next. So pull the first document. I should be able to do that. Do I want to verify the contents here? I could verify that the contents of that document match what I pulled out of the file. I could do that here. Or I could do that in my collection tester as well, right? Kind of depends on how you view the setup of this assignment. But then regardless, I should be able to assert true, not hash code, that there's still more documents, right? And then I should be able to pull the next one. D2 results.next. Pull second document. Verify contents. I'll make that note here too. But regardless, there's still one more, so I should be able to call hasNext again. Still one more document. And then I should be able to pull that last document, just like it's getting a little repetitive now. Pull last document. Now hasNext should be false. There's no more documents. I pulled them all. hasNext should be false. So assert false results.hasNext. Right? This is maybe not the best test I've ever written in my life, but it does test some of the methods from the cursor class. We actually kind of touched on all 3 of these, right? But I'm going to put done here with question marks and see if you guys are satisfied that this test has convinced you that those methods all work properly or not. There may be some additional work to be done here. All right. I'm going to save and commit these, so you're going to have at least 4 tests that you can use to get you started on. You're going to need more than that. You're going to need more than that for sure, but you're on the hook for the rest. Are there any questions that I can answer for you all about this assignment, about the unit tests, about anything at all? Yes?
Just to confirm, the unit tests are due at the same time as the test.
Yep, there's no special due date for this one. Everything's just due last day of class, December 6th. Yeah?
And do you have your own unit test you're going to evaluate us on? Or is it
I do not have my own unit test because part of the deal with asking you to write unit tests is that you get to tell me the intended behavior of this assignment, right? And so it would not be reasonable for me to expect everybody's to conform to the exact same set of behaviors. I do expect them to be mostly the same because I've given you a list of requirements, right? And you're going to be trying to meet those requirements. But the details of how you meet those requirements might change a little bit. And so from that sense, you know, there might be some variations that would make it unreasonable for me to run my own tests. So the grading process, since that's what it really boils down to, the grading process looks like this. I'm going to look at your tests first. That's the first thing I'm going to look at. I'll look at your tests. I'm going to see if the tests seem reasonable. Are they doing a good job of covering the requirements that you were asked for, right? Or did you try to give me the bare minimum of tests, right? That's what I'm going to look at. Do your tests seem reasonable? Are they testing reasonable things? I'm going to run them, and I'm going to assume that they're all going to work and that you wouldn't give me tests that don't work. Although actually, it might seem counterintuitive, but giving me tests that don't work is not necessarily a bad thing, right? It's not the greatest thing in the world, but I do appreciate you admitting that there is functionality that you think this should have that just didn't quite get there. Like that's honesty, right? And I certainly would appreciate that honesty if that is in fact the case. If I look at your tests and the tests seem like they cover the requirements and the tests are all functioning, we'll review your code just to make sure that nothing crazy is going on in terms of hard coding or anything like that. And at that point, we're good to go. I can do a lot of grading. I can tell you a lot about a program just by examining these unit tests. I am still going to look at your code too, right? But your unit tests will go a long way towards how this assignment is graded. So use that to your advantage. Make sure your unit tests look awesome, because that's the first thing I'm going to look at. If I look at your unit tests and there's some problems in there, then I'm going to start to feel a little sad about having to grade the rest of the assignment. Right? Spend some time on those tests. Do those tests first. Any other questions? All right, I gotta be honest with you guys. I am in a lot of pain up here. I don't want to talk anymore. So I am gonna go ahead and let you all cut you loose on this assignment. If you want to hang back and ask more questions after class, I'll stick around until 3:50. But I need to give myself a break. So I'll get homework 3 graded as soon as I can. Have a good week. I'll see you on Wednesday.
If the file formats are just key value store embedded or array.